Hello, hi everyone. As you know that in the previous class where we have left, we have completed the 5 state of the balancing chemical equation. In the last 5 state, we have balanced the chemical equation. It is enough until to the last step that we have done up to the 5, or we need to do some one extra step that will make our equation more informative than it was up to the fifth step. So our next step 6, that is what that is in that step 6 we will make our equation more informative than it is present into the step 5. What we did the training, we just represent the physical state of our reactant and product. Our in the equation they are the reactant and product. Our reactant and product are present in which state? In order to represent their state, we have used small words. Just like to in order to represent the gaseous form, we just use the small g. Similar way we use the to represent the liquid form, we use the L, small l. To in order to represent the aqueous form, we use the AQ, and to represent the solid form, we use the S. So simply mean to say that in our reaction, our reactant are product. These are our form of the matter, and the matter exists into the any state of. There are the 3 or 4 state of the matter. There are the 3 state of matter, and matter will exist in the one state. So in order to make sure that our matter exists in which state, or our reactant or product exists in which state, we use the different types of symbols in order to represent their states. So if our reactions includes the catalyst or temperature or pressure, in order to represent the pressure, catalyst or temperature, we use the temperature, pressure, catalyst above or below the reactions in an equation. So now here is the new word come. What does aqueous mean? The aqueous mean a solution which is our reactant or product when dissolved into the liquid. Liquid means water. When our reactant or product dissolve in water, it will present alongside with the water, then we use the term aqueous in place of their state. Just like for example, if you take the glass of water and put into a water and put it to 1 spoon of a glucose. Now as you know that when we have taken the water, it is present into the liquid form, and the glucose, it is present into the powder form, simply say that into the solid form. When we have put the glucose into the water, then glucose completely dissolved. Now can you determine what is the state of a glucose? It is impossible or difficult for us to define the glucose either into solid form or into a liquid form. So we have used a new term. What is that? Aqueous. Aqueous means that glucose, it is dissolved into water. Just learn one thing. We use the aqueous only in one condition: when our reactant or product is dissolved, are present alongside with the water, not with any other liquid. If we have put the glucose into the kerosene or into the petrol, then we will not use the aqueous, because aqueous is used when our reactant or product are present alongside with the water. So it is a thing that you need to mind yourself, or you need to learn. So why we have used the step 6, why we have enlarged the one further step, that why we are representing the physical states of our reactant or product, or why we are using the temperature, pressure, catalyst information above the arrow or below the above or below the arrow, in order to make our equation more informative than it was present into a step 5. So next point that is written, that it states that it is not necessary for us for all time to represent the physical states in each chemical equation. Whenever it is required, then we will use it. If it is not required, then we will not use our physical state in each and every chemical reactions. You need to learn one thing. So where it is required, you have to use it. If it is not required, then you do not use it. And there is an example in order to make our learning more simplicity. So there is a question. What is that? When carbon monoxide react with the hydrogen, it will form the CH3OH. Sorry, carbon monoxide react with the hydrogen gas, it will form the methanol. Now, if you will only look the equations in the symbol form, it is represent CO, and after that CO, there is a representation of a G in the bracket. So what does it mean or what does it represent? The carbon monoxide, it is a reactant that is present into the gaseous form. Similar way, in front of the hydrogen, here we also use the G, and it also represents that hydrogen is present into the gaseous form. At 340 atmospheric pressure, what it will give? It will give the CH3OH, or simply we say that methanol. And the methanol is present into the and the representation after the methanol is in the bracket small l, that represent the methanol is present into the liquid form. So if we will not use the small symbols after the reactant or product symbols, then we will not know the state of the reactant or product. Whenever we have used it, now right now we know that what are the states of a reactant or product, in order to make sure that it is performing at a particular pressure. Of course it is performing at a particular pressure. What is that? At 340 atmospheric pressure. Hence we have written the data of pressure above the equation. Now there is another example of the photosynthesis reaction. Photosynthesis reaction also perform, it is also type of a reaction that is performed into the plant body in order to make the food. How it perform? When the carbon monoxide react with the water, it will form the glucose along with the oxygen gas along with the water. So that carbon dioxide is present into the plant in the gaseous form or something else. It is present into the aqueous form. Aqueous means that carbon dioxide gas is dissolved into the water when the reaction performed with the help of sunlight and chlorophyll. So sunlight, it is a physical factor, and chlorophyll, it work as a catalyst. We can say that it is a condition in order to change these reactant into the product, and we have obtained the glucose, oxygen and water. And further, the glucose is also dissolved into water, hence we have used the aqueous term in front of the glucose. Now here our step 6 is completed. If the equation come into our exam, in order to balance it, we just need to balance the equation up to the 5th step. If it is required, then you should use the step 6. Otherwise you have not to use the step 6. Doing equation or balancing equation up to the step 5th, it is also considered as a right. Now next is what is the types of a chemical equation. There are the many types of the chemical reactions, in which way the chemical reactions or reactant or product are combining, or they are reacting. On this basis there are the more types of reaction. So the first type is combination reaction. As you know that combination is, the word is derived from combine. Combine means addition. Hence the second name of that reaction is addition reaction. When two or more reactant combine to form the single product, then that type of reaction, it is known as the combination reaction. As I have given the example, when A react with the B, it will form the C. Hence it is known as by the combination reaction. Here are the two reactants. One reactant name is A and another reactant name is B. When they combine, then they form the single product. What was it? What is that? That is carbon. And hence we have said that it is known as by the combination reaction. I hope so that you have learned it, and we will continue our next different types of reaction into our further class. So it was the first type of the reaction, that is what? Combination reaction. I am repeating again that when two or more reactant combine to form the single product, it is known as by the combination reaction. There is also an example of the combination reaction. We will continue that example into our next class. Goodbye students.